We're looking at the problem with the 5 friends and the 4 chocolate bars. And I like this problem because it shows something really important about fractions, which we'll get to at the end. And so I've seen 2 different ways to solve this problem really often every year that I do it. And what's neat is that there can be more than one correct answer depending on how you solve this problem. So I'm going to show you 2 different ways here. And so I'll split this board in half. We'll call this solution 1, we'll call this solution 2. And when we're talking about splitting up fractions, I always tell students to draw it out, because it's really a lot easier to kind of organize your thinking and to see things when it's visual like that. So we're going to draw out our 4 chocolate bars. 1, 2, 3, 4. I also tell students all the time, it's way easier to use rectangles when doing fractions as opposed to circles. It's a lot easier to split a rectangle into uneven amounts than it is try and split a circle into fifths, for example. And I always tell students to label your friends. So we're going to just call our friends A, B, C, D, and E for now. And so what usually students do is they split each chocolate bar into 5 pieces. And that makes a lot of sense to me. So we're going to go ahead and do that. So we split each 4 of the 4 chocolate bars into 5 equal pieces. And then we can just start doling out our pieces. So we can say, well, that's going to A, B, C, D, and E, A, B, C, D, and E, A, B, C, D, and E, A, B, C, D, and E. And when we look at this, students will say one of 2 things, but really they're saying the same thing. They'll say that each person is getting 1/5, because A, for example, in this chocolate bar is getting 1 out of 5 pieces, or they'll say that each person's getting 4/20. And both are right, because these are equivalent fractions. Because if we times the top and bottom by 4, 1/5 is the same as 4/20. And we've shown that right here. So 1/5 is correct. We'll write this here. We've seen that. Yes, each friend's getting 1/5. The other way that people often solve this, and this is where it kind of gets, I find this pretty interesting, is if we draw out our 4 chocolate bars again, and we split them, I should have drawn them bigger, we split them into 5 pieces. And we've still got our same 5 friends. But now, instead of giving 1 piece per chocolate bar, we're just going to go, well, this person, A, is getting these first 4 pieces. And now B, and B, and B, and B. And then C, and C, and C, and C. And then D, 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 D. And then E, 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 E. And so this person might say, well, every person's actually getting 4/5. Now 4/5 and 1/5 are not equivalent fractions. They're not the same number at all, and yet both answers are correct. And this is where this gets really important, is when we're dealing with fractions, we have to say what the fraction representing. So if we were to say, well, each person here is getting 1/5 of each chocolate bar, each is the really important word there. And then that answer is correct. Or we could say that each person's getting 4/5 of a chocolate bar. And A is the really important word there, because every person in this case is getting 4/5 of 1 chocolate bar. Every person here is getting 1/5 of each chocolate bar. And so even though 4/5 and 1/5 are not the same number, in this case, they're both correct answers because we've split our fractions differently. So what's really, really important, and the takeaway I want you to get from this is that when we're talking about fractions, we need to clearly say what our fraction is representing. What is the whole that we're talking about? Because fractions represent pieces of a whole. So we need to say what is the whole that this fraction is representing.